In this video presentation lesson, we'll use a calculator to formulate daily tool-time performance for heavy industry shutdowns, turnarounds, and outages. Note, this same calculator formula can be used for routine maintenance and projects. Before we begin, we're going to make some assumptions. 1. A productivity factor is applied to direct benchmark estimates on step-out plans, and all activities are direct tool-time related. In other words, we have not padded hours to make up for non-productive time, nor have we added any indirect activities into the step-out plan to make up for safety meetings, permitting, breaks, travel, etc. 2. We consider performance PF, uppercase P lowercase f, as an outcome of how well we planned and estimated. 3. 1.0 is our target. Anything greater is higher performance. Anything less is underperforming. 4. We apply productivity factor during scheduling, not during planning and estimating. This allows us to run various what-if scenarios to determine the most optimized plan, lowest cost, shortest duration, fewest resources. Let's look at scenario 1. Here we use a productivity factor of 1, which means for every hour planned we expect to earn the equivalent. This would assume that the estimates already include non-productive time, which is not a best practice, but is often the case. The direct tool time planned for the next 24 hours is 5,200. With a PF of 1, the plan value, PV, will be the same. If we earn the 5,200% complete, we'll calculate a schedule performance indicator, SPI value of 1.0. Next, we'll determine how many direct field labor hours we paid for, based on timesheet data. Note, timesheet data is collected daily and must be made available within 24 hours. These are the actual value, or AV, which come from a financial software involved in the event. In this case, we paid for 5,200 hours of field labor, which means we achieved a perfect cost performance index, CPI, of 1.0, again, assuming planning and estimating was padded to make up for non-productive time, and again, not a best practice. However, when calculated, SPI times CPI, the performance, tool time, is perfect at 1.0. Now let's assume that all planning and estimating was done with industry-standard tool time benchmark hours only, and no indirect activities were added to the step-out plans. In scenario 2, we're going to apply a PF of 1.3 during scheduling to make up for non-productive time, complexity, weather, competency, or any number of reasons for non-productive time on a STO event. Using 5,200 again as our desired plan for the next 24 hours, we can see that the most we can earn is 4,000 due to the PF of 1.3 to make up for non-productive time. Again, this is a best practice, adding PF during scheduling, not during planning and estimating. Instead of earning 5,200 direct tool time hours as we did in scenario 1, we'll assume we only earn 3,800% complete on the planned activities, and remember, you cannot earn more than planned on a single activity. However, you can earn more than planned in a 24-hour period. For example, if we did extra work that was not scheduled for that day, we could earn more than the 4,000 planned with the 1.3 PF. Using the formula of EV divided by PV, we can compute an SPI of 0.95. Once again, the earned value of 3,800 is divided by the direct field labor actual value, measured in currency. If we determine from timesheets that we paid for a total of 4,600 direct field labor, note, this does not include indirect support costs, we can divide the EV of 3,800 hours by the AV 4,600 hours and calculate a CPI of 0.83. Now, SPI times CPI equals 0.95 by 0.83, we calculate a performance factor of just 0.78, which in the STO event industry is not bad, provided the PF has been applied during scheduling to make up for non-productive time. If you'd like to learn more and receive a copy of this tool time performance calculator, register as a sustaining member today and join hundreds of career-minded planners, schedulers, and controllers who recognize the value of earning a digital credential badge for the benefits and rewards it provides.